Hello, we're here to do a little demo for you guys. This is a Charles Law demo. We really didn't get a good Charles Law kind of thing going, simulation, so we're gonna do this. What I have here is a can of Coke, and it's got some, put a little water in there and it's steaming up. So I've got some gas in there at a certain temperature. I'm gonna take this and I'm gonna go ahead and put it in the water. This is a ice water bath. So it's gonna go from this temperature where the water is steaming out to the temperature here where it's gonna be really cold. So let's watch what happens. All right, ready? Here we go. 1, 2, 3. Oh, look at that. I didn't do it. It did it on its own. Let me go ahead and put it down right here. What happened there? Well, looks like the temperature dropped. So as the temperature dropped, so did the volume. It wanted to be a smaller volume because the temperature was less, so the volume was less. So this goes along with our Charles Law. Volume and temperature are directly proportional, which means as temperature rises, so does the volume. But here what we had is temperature dropping. We had a high temperature, 100 degrees Celsius, maybe a little more, and we have the gas in here at that 100 degrees Celsius. We put it in here where it's about 0 degrees Celsius, dropped the temperature, the volume wanted to change accordingly, and look what happened. And let's do it one more time. Okay. I'll show you how to get this going. All right, so you got your Coke can, and I'm gonna put just a little bit of water in there, not too much. I'll put it on there. This thing is hot, so I'm not gonna touch that again. Probably best to have these things here. And I'm gonna go ahead and let it go ahead and start heating up, and we're gonna go ahead and get it to boiling again. At least steaming a little bit. When it starts steaming on the inside means we're ready to go. So hopefully it won't take too long. But at this point here, this is kind of cold, and you can see kind of how the whole thing imploded. I didn't do it with the tongs because it wouldn't have crushed this way. It was just the fact. Actually, you know what did this? It was atmospheric pressure. The pressure on the outside. Sometimes we think, there's not a lot of pressure in the atmosphere, right? It was the atmospheric pressure on the outside pushed it in. The pressure on the inside was at 1 atmosphere pressure, and as it cooled, the pressure went down from 1 atmosphere. So now the pressure on the outside is higher than the pressure on the inside, and it just kind of smashed it up. Okay, so we're going to go ahead and do the second one here. See if it doesn't take too long to go ahead and heat up. No, it looks like we've got some steaming coming around here, so I'm starting to hear it again. Okay, so we're going to try the second one. Okay, here we go. Let's see if we can get kind of a similar thing. I don't know if it'll do it as spectacularly, but oh, I hear some noise. We've got it bubbling. So here we go. Ready? Hold it right here. 1, 2, and 3. Well, there was a little bit of delay on that one. Not as much. The first one was a little more spectacular. I think I didn't let it heat up as much. And let me go ahead and turn this off before I burn something. But we still got the temperature dropping and therefore the volume dropping. Okay, so hopefully that shows you Charles' Law, how volume and temperature are related to each other. All right, catch you on the flip side.